Hi everyone, this is Ankita Arun Palande and today I will be presenting my data analysis project on credit risk analysis by using Power BI. So first we will see objective of this project. So first I aim to assess loan risks by evaluating how likely a borrower is to default based on their financial profile. Then I focus on identifying high risk borrower using key financial and credit factors to help lenders flag potential risks early. Then I aim to aid decision making by offering clear insight through visualization supporting more informed loan approval. Then finally I work to improve lending strategies by helping institutions understand borrower behavior and reduce overall risk. So first we'll open the Power BI and load the dataset. So I have already done this. So for this I have used DEX measure. First we will see for average loan amount. This is the formula for average loan amount. This measure calculates average loan amount for each loan grade, ignoring all other filters by using all except to keep only the loan grade filter active. Next, we will see for average interest rate. This is the formula for average interest rate. This measure calculates average interest rate for each loan grade while ignoring all other filters using all except. So the grouping is only based on loan grade. Next, we will see for default rate. This is the formula for default rate. The formula calculates the default rate by dividing number of defaulted loans, where loan status is 1, by the total number of loans, both filtered by loan grade and returns 0 if the denominator is 0. Now for visualization, I have used scatter chart. This is the scatter chart. On x-axis, I have added average loan amount, and on y-axis, I have added average interest rate. These are the DEX measure which we created now, and in legend, I have added loan grade. Also, you can see there are different sizes of bubble. Each size represents default rate. Smaller size means less default rate, larger size means more default rate. If we see on left side loan grade A, which is in blue color, it is having less loan amount, which is 8,545.70, then less interest rate, which is 6.65, and less default rate, which is 0.10. And if we see the yellow one, loan grade G, it is having higher loan amount, which is 17,195.70, then higher interest rate, which is 18.67, and higher default rate, which is 0.98. Also, if we see group T to G, they are having higher loan amount, default rate, and interest rate. So, this group are riskier. Then, if we see loan grade A and loan grade B, these are safer because they're having low loan amount, interest rate, and default rate as compared to other grades. Now, moving to question 2. Create a report visualizing the distribution of loan status across different employment length and home ownership status, which combination shows highest default rate. So for this, I have used cluster bar chart and one slicer for filtering the data. First, we will see first chart. So on x-axis, I have added loan status. On y-axis, I have added person home ownership, which is rent, mortgage, own, other. And in legend, I have added loan status. 0 is for non-default and 1 is for default. So you can see green color is for non-default and red color is for default. So here we have to find highest default rate. So one is for defaulters one. So if you see rent, there are two bars. So green color is for non-default and red color is for default one. So rent, it is having highest bar than the other. It means it is having highest default rate. Now moving to second chart. On x-axis I have added loan status. On y-axis I have added person empire land, which is starting from 0. Then you can see 10, 20, 30, 40. In legend, I have added loan status, which are having 0 means non-default and 1 means default. So here also we have to find highest default rate. So you can see the first bar, red color, person with 0 ampere length. You can see person with 0 ampere length, it is having highest default rate. So in this both, we have to find the highest default rate. So if we see count of rent, it is 5177, and if we see count of person with 0 ampere length, it is 1424. So here rent is having highest than this one. If we want to see only defaulted one, so in slicer I will set it to 1. So it will only show data for defaulters one. As you can see, both charts get updated. Also it will show data for non-defaulters one. You can see green color means non-defaulter for both the chart. Now, as you can see, renters they have higher default risks because most default come from renters showing financial instability. Then longer employment means lower default risks, where job stability is linked to fewer defaults. Also, bank can request additional guarantors or higher interest rate for applicant with 0 year of employment or rentals. Now, moving to question 3. Segment the borrowers by loan intent and visualize the average income and average loan amount for each segment, which intent has the highest loan amount to income ratio. So for this, I have used DEX measure. So first one is average income for segment. So average income for segment. So this is the formula for that. So this formula calculates average annual income for each segment in the data set. Next one is average loan amount for segment. So this is the formula for that. So it computes the average loan amount for each segment by calculating the mean of the loan amount column. Next is loan to income ratio. So this is the formula for loan to income ratio. So this formula calculates loan to income ratio by dividing average loan amount by the average income for the segment. The first two measure which we created, it will divide this both. Now for visualization, I have used two cluster column chart. So we will see first one. On x-axis, I have added loan intent, and on y-axis, I have added average income and average loan amount. Also, you can see there are two bars. So one bar is for average income and second bar is for average loan amount. So if we see home improvement, it is having highest average income, which is 73,575.11. And if you see the last bar, which is smaller than the other, it is for medical. It is having less average income, which is 61,476.83. Now moving to second chart. On x-axis, I have added loan intent. On y-axis, I have added loan to income ratio. So here, if you see first bar, which is higher than the other, which is for medical, so it is having 0.15 loan to income ratio. And if we see the last bar, it is for home improvement. It is having 0.14 loan to income ratio. So here, it suggests that these borrowers are generally more financially stable, the home improvement one. Then, moving to question 4. Consider CB person credit history length has a time dimension. Analyze how the loan default rate has changed over the years. Implement a time slicer to adjust the view period. So for this, I have used DEX measure formula. So default rate for loan, this is the DEX measure. So this DEX measure calculates the default rate by dividing number of defaulted loans, where the loan status is 1, by the total number of loans with a fallback of 0 to avoid division by 0. So for visualization, I have used line chart and slicer for filtering the data. So on x-axis, I have added CB person credit history length, which is starting from 0. Then on y-axis, I have added default rate for loans, the DEX measure, which we created. So here, person with shorter credit history length, such as 2 to 4, you can see, they are having higher default rate, which is 0.237. And if I set it to 5 in slicer, you can see person with credit history length 5 to 6 years, they are having 0.208 default rate. And person with longer credit history, such as 9 to 10, they are having less default rate, which is 0.203. Then the default rate is not purely linear, as it picks for borrower with 8 year of history. So for 8 year of history, the default rate is 0.14. So this suggesting that credit risks can vary significantly within mid length histories. Then moving to question 5 here. Create a what if parameter to stimulate different scenarios based on varying interest rate. How do changes in interest rate potentially affect the default rate? So for this, we have to create what if parameter. For that, we have to go into modeling tab and then new parameter here, then numeric range, then one pop-up will come. So it will take a second. Then in numeric range, you have to select numeric range. In parameter, you have to give name for the parameter. So I have given interest rate scenario, interest rate scenario. Then in data type, I have chosen decimal number. Minimum means less interest rate, maximum means largest interest rate. I have kept 30. Then increment means step size, so I have kept 0.5. Then default will be empty. Then this will add slicer to this page. Then click on create. So you can see it has been created. Now for visualization, I have used line chart. On x-axis, I have added interest rate scenario, and on y-axis, I have added default rate with interest. Here you can see on x-axis, the interest rate starts from 0, 5, 10, 15, 20, and the default rate starts from 0.00 to 0.20. Here you can see. Now, the yellow line, it indicates a negative trend, this yellow line, suggesting that as the interest rate increase, the likelihood of default rate decrease significantly. Here you can see interest rate is increasing from 0 to 5, 5 to 10, and the here line, it is declining from here to here. Here default rate is decreasing. So here the value dropped sharply from 0.22, you can see 0.22 in white box to near 0.00. You can see 0.00 as the interest rate moves from 0% from here to around 20% here, indicating a strong inverse relationship. Now in slicer, if I set it to 17.16, this is the interest rate I am adjusting. You can see chart is updated. So as the interest rate moves closer to 20 here, the default rate drops significantly, reaching around 0.19. You can see 0.19 here. So insight is that investors can prefer banks with low default rate and high interest margin, potentially increase stock prices and market valuation. Also, bank can earn more interest income from loans as the interest rises. So this directly boosts their net interest margin, which is NIM, which is a key measure of profitability. Now moving to question 6. Here, question is, if geographic data such as state and city were available, how will you visualize loan distribution and default rate across different regions? So for this, our current credit risk data set, it does not include geographic data like state or city. So without this information, it is not possible to perform this analysis accurately. If such data were available, I could have used Power BI's geographic visual such as heat map, then bubble map or fill map. So these are these map. This is the fill map. Then to identify regional trends in loan behavior and default rate. This visual can provide valuable insight into regional lending risks and help identify high risk areas for targeted risk management. Now moving to question 7. Write a DEX formula to calculate the risk score for each loan, considering factors such as loan amount, person income, default history, and employment length. Define the risk score formula based on this factor. So for this, I have created DEX measure, that is risk score formula. So this is the formula for risk score. This is the formula for risk score. This formula considers loan amount, person income, employment length, default history, and interest rate to calculate the overall risk for each borrower. And for visualization, I have used table, as you can see, and slicer. So the table shows key detail for each loan application in our data set. It helps us understand the borrower's profile and risks involved in approving the loan. So here we have loan amount in the first column, then their annual income, then person empire length. So these three factors, they help us judge their ability to repay. We also have a column showing whether the borrower has a history of default, CB person default on fine, N means no and Y means yes, then which is a strong indicator of risk. Then the interest rate on the loan is shown here. This one, loan interest rate, which is important for calculating expected returns and risks. And finally, the risk score formula. It is a calculated score that combines all these factors to estimate likelihood of borrower defaulting. A higher score means higher risk. So if we see loan amount here is 3000, so here risk score is 7.81. Here you can see the loan amount is 6000, the risk score is 8.68, and here the highest one you can see 13.07 for the loan amount 3000. Now moving to question 8. Here RLS, which is row level security in Power BI, is a powerful feature that allows us to control data access at the row level, ensuring that users only see data relevant to their rows. So first of all, we have to go into Modeling tab, then click on Manage Role. Here one pop-up will come. Then here you have to create new security role and use filter to define role level data restriction. So here you have to define role. Click on New. Then you have to give meaningful name. So I have given home ownership. Then here you have to select a table. I have choose credit risk dataset. Then in the filter section, in column, I have choose person home ownership. In condition, I have applied equal. In value, I have choose own. Then you have to click on save. Now to check the filter is working correctly, we will go into view as here. Then you can see there are options. So here I will click home ownership. Then I will click on OK. Then it will only show data for own. You can see here it is only showing data for own and all other data is hide. Now again we will go into view as, then we will click on none. OK. Again the chart is updated, pie chart. Now moving to question 9, dashboard creation and publication. So here we have to design a comprehensive dashboard that includes all of the above analysis, include navigational features and tooltip. How will you publish and share this dashboard with stakeholder in Power BI service? So we will see one by one. So first one is scatter chart. So here loan grade A, it is having less loan amount, interest rate and default rate. Loan grade G, it is having higher loan amount, interest rate and default rate. Then in this second chart, it is cluster column chart. The home improvement is having highest average income and medical is having lowest. Then in this second cluster bar chart, rent second bar, it is having highest default rate as compared to other. Then in this table it shows risk score for each loan amount. As you can see, for loan amount 5,000 the risk score is 0.01. Then in this line chart, it shows interest rate for has the interest rate increased, the default rate decreased. As you can see, the line is coming down. Then this is the line chart. So it shows person credit history. So person with shorter credit history, the default rate is higher. Here you can see for 5 and 6 it is 0.28, and person with credit history 9 to 10, the default rate is low. Also I added slicer. Now we will see publishing the dashboard. So for that you have to open your Power BI desktop file. Then you have to go into file here on left side. Then after going to that, you have to click here on publish. Then you can see here option publish to Power BI. Then here you have to sign in, prompted. Select your workspace and hit the publish. This will upload your report to the Power BI cloud, making it accessible online. Now we will see sharing the dashboard. So for that, open Power BI service. Then you have to find your report in the correct workspace. Then pin the visuals to new or existing dashboard. Now we will see. Now this is the end of my presentation. Thank you for your attention and time.